Hi dear students, now we will look at some work examples which explain about integration by substitution method. So if we wish to perform integration by substitution, we're going to use the rule of introducing u as a function, and then we need to differentiate that particular u function in order to substitute in terms of u. So we are going to change example a function in terms of another unknown u, and then integrate and then substitute u in terms of the original function again. So how are we going to do this? Example, if you have a function which is integrate x multiplied by x squared plus 3 cube, okay, you can always expand this 3 times and then multiply by x and then integrate individual terms, but an easier way or approach would be integration by substitution. So what you need to do is you need to take a function. So there are two functions here, which is in terms of x and also x squared plus 3, and when you differentiate x squared plus 3, you will get a function which is in terms of x. Okay, so usually we choose the one with the higher power as the u. Okay, so when we choose the u as x squared plus 3, when you differentiate, you'll get du dx would be 2x. So you can bring the dx up in order to ease your substitution. Okay, for example, over here you can actually substitute your x dx as du over 2. Okay, example like that, it will be x dx will be substituted as du over 2. Okay, you bring the 2 over here and then you get x dx. So you can substitute x dx as du over 2. All right, and then you would substitute your x squared plus 3 as u into the integration. And now we integrate in terms of u first. So you will get u4 over 4, which will result in 1 over 8 u power 4 plus c. Don't forget, it's an indefinite integral without limits, so there is a c. And next, you need to substitute back the function in terms of x, because the original question required you to integrate in terms of x. Okay, when you sub u back in, you will actually arrive to the final answer. Okay, so similarly, the next example, if you have a function as 3x squared, all right, and then you have x cubed plus 4. So automatically the function that I highlighted in green would be the function which you will choose as the u. Okay, so for example, you would actually choose the x cubed minus 4 as the u, and when you differentiate it, you are able to substitute du dx will be 3x squared for this function, and you can write du as 3x squared dx, and you realize that 3x squared dx is actually 3x squared dx is actually the in terms of the original function. So you can substitute 3x squared dx as your du. Okay, and then this part here, which I underline now, which is actually x cubed minus 4 would be your u. So you can reduce this function to integrate u power 5 du, as written over here. Now you need to integrate in terms of u. So when you have converted the function in terms of x in terms of u, you should be able to integrate it with respect to u. That's why there's a du here. Okay, so you'll get u6 over 6 plus c, and then substitute back in terms of the original unknown. In this case is x, because the original question actually requires you to integrate with respect to x, which is dx. So your final answer must be in terms of x. Okay, so next we will visit another example which involves cosine and sine cube. So as I said earlier, usually you choose the function which is in with a higher power. So there's a cos and there is a sine. You're unable to integrate this using the general integration formula. So automatically you will use sine x as your u. Okay, so you will let u be sine x, so du dx would be cos x. All right, for in order to ease your substitution, so you will bring the dx up here, and it becomes du equals to cos x dx. So you're able to substitute cos x dx as your du. So the 8 would remain there as a constant. Okay, so you need to convert sine cube as u cube because u was sine x earlier, and the 8 would remain there because it's a constant. And now once you have reduced all the x function in terms of x in terms of u, so you need to integrate with respect to u. So when you're integrating with respect to u, it will be u4 over 4, which will reduce 8u cubed to 2u4 plus c. And then finally, you need to substitute in terms of x again because you are required to answer the original question, which asks you to integrate with respect to x. So the final answer will be 2 sine power 4x over, plus c. At times, the substitution will not be so obvious. So if you're not given the substitution which is obvious, sometimes you need to think a bit further in order to choose your u. So example, question like this, you have 4 ln x over x dx. This is quite obvious. You can't actually solve this integration by using the general integral formulas that you have learned in the last semester. So in order to substitute, you think a bit further. Ln is a function that you can't integrate. So obviously you need to take the ln as a u so that you're able to substitute it in terms of u to allow integration. So if u is ln x in this case, okay, the reason we choose u as ln x because differentiating ln x will give you 1 over x. So you should be able to identify the pattern. Okay, so u is ln x du dx 1 over x dx. So you're able to substitute 1 over x dx as a du. All right, and this integration will reduce to 4 u du. Okay, so once you have converted x, the function in terms of x, to function in terms of u, you can integrate with respect to u. Okay, so you will get u square over 2, so that will reduce to 2u square plus c. Okay, finally, as I've explained in the earlier examples, you are required to integrate with respect to x, so you need to convert u in terms of x again. Just substitute u as ln x over here, and this would be your final answer.